Okay, so next we're going to use this idea of bond energies, and we're going to do, well, we're going to do some math with it. So sharpen up those erasers. Here we go. All right, so we're going to use bond energies to estimate our delta H of reactions. So this is going to be very chapter 5-esque. A lot of you just stiffened up in your seats right now. Endothermic, exothermic, oh boy. All right, there you go. You've all been thoroughly triggered now. Okay, so our bond energy, we're going to say, well, that's about delta H bond. It's not perfect, but it's good. So that's why I'm using the word estimate up here. We're not exactly calculating certain conditions. It's a better estimate than others. We're not going to worry about that. So, you know, we use our bond energies from the table I mentioned before. And we just say, okay, well, that's delta H of bond. And then we plug it into a formula that'll look very familiar. Just a slight tweak on something we had before in chapter 5. So our delta H of reaction is equal to the sum of all of our delta H's of bonds breaking. These are going to release energy when we break them. And then we have to put energy into forming bonds, so we're going to subtract the sum of the delta H of all our bonds formed. So this should seem very familiar. We looked at like something like delta H formations before. We're just swapping delta H formations for delta H's of bonds. So we're getting a little bit more granular with this, a little bit more smaller pieces. Before we had gravel, now we're looking at sand. All right. And so for an example, let's look at the combustion of ethene gas. So a combustion reaction. We're going to light some ethene gas on fire. Ethene gas is CH2, CH2. And we've done the whole balancing act before, so this is a fully balanced chemical equation we're starting out with here. We've got our ethene gas, our oxygen gas. We're going to make CO2 and water vapor. All right, so there's a new step. So we don't just look up delta H formations. Now we got to go, what are the structures of these compounds? So Lewis structures are getting folded into this topic now. And so if you want to take a minute, take a shot at doing your Lewis structures, go and pause it and give it a shot. Otherwise, I'm going to get right to it. All right, so our ethene is going to be 2 double bonded carbons. We're not going to worry about that. We'll just go up, down with 2 hydrogens on them. Okay. Oxygen gas is 2 double bonded oxygens with lone pairs. And then CO2, carbon double bonded oxygen, carbon double bonded oxygen, and H2O, H, 2 lone pairs on the oxygen. So that's our Lewis structures of all of our products, all of our reactants. So these are the bonds that we're forming, and these are the bonds that we're breaking. So we got to total this up. So we have 1 mole of this. So we have, or should I write that right here? We got 1 mole of CC double bonds, 1, 2, 3, 4 moles of CH single bonds, because there's 1 here, 2 here, 3, 4. We're breaking all 4 of these. If there's 1 mole of this, there are 4 of those. So that's what's happening. We're going to break 3 moles of O double bonded to O. That's the bond we're breaking right there. We are going to make 2 moles of this compound. So we got 1, 2. So this is going to end up being 4 moles of carbon double bonded to oxygen. And then we're going to have 2 times 1, 2. So we're going to have 4 moles of hydrogen bonded to oxygen. Single bonded, okay? So these are broken. These are formed. We form our products, we break our reactants, we break our reactants apart. Think about it, we break all these bonds, you know, take the whole Lego set apart, and we make new stuff out of them. We make whole new bonds. So our delta H of reaction is going to be the following. So we have to look up what these values are in table 8.3, which we can do no problem. And so we see that we have 413 kilojoules per mole times 4 moles. So that's our CH bond. We're going to add to that 614 kilojoules per mole. Again, I'm just getting these numbers off the table. You don't need to memorize them. Times 1 mole, so that's our carbon-carbon double bond, which we actually had on the table before. We got one more. We got the oxygen-oxygen double bond to work in. And so we're going to have 495 kilojoules per mole times 3 moles. So that's our O2. Okay, so those are all the bonds that we are breaking. So now we've got to subtract the bonds that we form. Okay, so we have 4 moles of carbon-oxygen double bond. So we're going to go look at our table. We see that's 799 kilojoules per mole. Okay, times 4 moles. Just again, right there. So we've done a lot of our legwork already. So now we're just pulling numbers off tables. And we're just going to keep subtracting now. We're going to subtract all of our bonds that we're forming. So what else are we forming? Well, we got 4 moles of HO. And so that is 463 kilojoules per mole times 4 moles. Now I don't have these written in my notes exactly. I might have them backwards, but anyway, that's all of that. And then we just sum it all up and we get negative 1,297 kilojoules. Or we can say that that is negative 1,297 kilojoules per mole of ethane gas that we combust. And so again, let's just kind of back up. Let me get my legs back under me. It's like a baseball catcher. Whew. All right, it's getting warm in this room too. We don't really have the HVAC system going. Don't they know that there's one person working in here today? All right, so we have to have a balanced chemical equation. That is step 1, all right? And that was given to us here. We've passed that, but it could still come into play. So make sure you know how to balance chemical equations. You should know how to do a combustion reaction. You have a CH compound, so some sort of organic compound with oxygen makes CO2 and H2O. All right, so here's the new stuff. So we've got to bring into play Lewis structures for every compound we're working with. And then we've got to get the moles of each type of bond laid out. So it isn't just enough to know it's 1 of these and 3 of these, but that it's 3 of these bonds and 1 mole of these bonds and 4 moles of those bonds. So we got to get all the types of bonds totaled up, and then we crank into the math. And then we follow the formula. So that is the process. So I'll throw some practice problems up for these. You get to work on. Feel free to refer back to this. Again, I'll make a key for them. So the last thing we're going to talk about, I'm also just tired because I've been filming all day, is going to be resonance, and that's a very tricky topic. So I'll try my best to guide you through that. It's responsible for a lot of the weird stuff in chemistry, but this is a lot of throwback to chapter 5 right here. You got your delta H's, you got your summation notation. And again, we're just doing this little trick. We just say, oh, the bond energy is about delta H bond, and that leads into boom, all of this. So we have to break these apart. How much energy is that? Okay, we account for that. All the energy gets released. All the energy has to get put in these new bonds. What happens there? So what we end up with is a exothermic process. There was more energy stored in these bonds than there was in the bonds we ended up with. And so where'd it go? Well, maybe it was used to heat some water or a house or whatever, welding torch, who knows? All right, so we'll leave it there. Practice, 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 all the worksheet up. And remember, most important part when you're doing stuff like this, have fun and don't trust your calculator.